So, what's up? What's up? What's up? What's up? Peace, peace, peace. This your girl Tiffany, coming through live in effect, and I'm back again. So this time, I am going to deal with a topic about quantum physics. So the question becomes: have the scientists solved, or are they coming closer to find the answers about quantum physics and consciousness as far as the relationship? So, reason why I'm doing this topic because there's some scientific sources that just came out from sciencetechdaily.com, and they were saying that scientists are closer to finding out the answers about quantum physics and also the relationship with consciousness. So, I'm going to explain why I support this view and why I support this position. So before I go there, I want to go ahead and just present the article to you guys. All right. All right. So right here it says, can consciousness be explained by quantum physics? Fascinating research take us a step closer to finding out. Now, I thought this article was pretty fascinating because I had posted up on Facebook and whatnot. And it says, one of the most important open questions in science is how our consciousness is established. So in the 1990s, long before winning the 2020 Nobel Prize in Physics for his prediction of black holes, physicist Roger Penrose teamed up with anesthesiologist Stuart Hameroff to propose an ambiguous answer, or ambitious answer, excuse me. They claim that the brain's neuronal system forms an intricate network and that the consciousness this produced should obey the rules of quantum mechanics, the theory that determines how tiny particles like electrons move around. This, they argue, could explain the mysterious complexity of human consciousness. And then it goes on down here, it says Penrose and Hameroff were met with incredibly quantum mechanical laws are usually only found to apply at very low temperatures. Quantum computers, for example, currently operates around negative 272 degrees Celsius. At higher temperatures, classical mechanics take over. Since our body works at room temperature, you would expect it to be governed by the classical laws of physics. For this reason, the quantum consciousness theory has been dismissed outright by many scientists, though others are persuaded supporters. All right, and then just kind of skip down a little bit. So it talks about the brains and fractals. Our brains are composed of cells called neurons, and their combined activity is believed to generate consciousness. Each neuron contains microtubules, which transport substance to different parts of the cell. The Penrose Hameroff theory of quantum consciousness argues that microtubules are structured in a fractal pattern, which would enable quantum process occur. And then also goes on to say fractals are structures that are neither two-dimensional nor three-dimensional, but are instead some fractional value in between. In mathematics, fractals emerge as beautiful patterns that repeat themselves infinitely, generating what is seemingly impossible, a structure that has a finite area but an infinite perimeter. All right, so this is the article here, and I'm not going to go any further, but if you guys want to check out the article, you can. I may come back to it. And the title is, Can Consciousness Be Explained by Quantum Physics? So you guys check it out. It's on Science SciTech Daily, scitechdaily.com. Just look it up. And it came out today on August the 3rd of 2021. All right. So now, where do I stand on my position? I personally support this argument, and I've I've been saying it for the longest. Like I've been telling other people, and the conversation I had, that there is some type of correlation between consciousness and quantum physics. So, for example, if we look at the bioelectromagnetism, right? So when you deal with the bioelectromagnetism, that deals with like all the, it's just basically electromagnetism in the human's body. So when we look at electromagnetism, and let's go back to what electromagnetism is as a recap. All right. So right here under electromagnetism is a branch of physics involving the study of the electromagnetic force, a type of physical interaction that occurs between electrically charged particles, right? The electromagnetic force is carried by electromagnetic fields composed of electric fields and magnetic fields. It is responsible for electromagnetic radiation such as light. As it is, it is one of the four fundamental interaction, which is commonly called forces in nature, together with the strong interaction, the weak interaction, and gravitation. At high energy, the weak force and electromagnetic force are unified as a single electroweak force. So, with that being said, let's look at bioelectromagnetism. So, bioelectromagnetics, also known as bioelectromagnetism, is the study of interaction between electromagnetic fields and biological entities. Areas of study include electromagnetic fields produced by living cells, tissues, or organisms. The effects of man-made sources of electromagnetic fields like mobile phones and the application of electromagnetic radiation towards therapies for the treatment of various conditions. And I'm just going to highlight this for a moment. And it also goes on and says, the bioelectromagnetism is a study primarily through the techniques of electrophysiology. In the late 18th century, the Italian physician and physicist Luigi Galvani first recorded the phenomenon while dissecting a frog at a table where he had been conducting experiment with static electricity. All right, and then going down, the bioeffects of electromagnetic radiation. So most of the molecules in the human's body interact weakly with electromagnetic fields in the radio frequency or low or extremely low frequency bands. So one such interaction is absorption of energy from the fields, which can cause tissue to heat up. More intense fields will produce greater heating. This can lead to biological effects ranging from muscle relaxation to burns. All right. So, with that being said, understand about the electromagnetic fields, right? In combination of the bio, which meaning that dealing with organism and human cells, it's only fair to make the argument that the quantum physics brings about correlation in the micro tubes, right, and the neuron cells. So in our neurons, right, there is some form of formation in the atoms. And then like with these particles, not only the particles can be found in space or subatomic particles, but it also can be found in us too. So I can give it a good example. Let's just say if somebody was to meditate. So if you're meditating and you're closing your eyes, you at a standstill physically, you're not moving, but your mind, your brain is moving, like that part of you, like your cells and stuff, they're moving around. So therefore, there's something that's working. There is some type of photon that's working inside the brain, which causes it to be able to stay in motion, right? And there's some type of particles that's in operation, okay? Now, some of us believe in panpsychism, which I also agree, which deals with inanimated objects, all right? So it's something that you can't really see with the naked eye per se, but you know it's there, right? So with these little tiny particles that's moving inside the neurons, inside the brain cells, in the brain tissue and all of that, that shows that it has to be some type of relationship with the quantum physics. Although quantum physics deal with the mathematics of the particles, meaning at the subatomic level, like the proton, neutron, electron, and the photons and all that. But still, there's some type of correlation. But the only people that can really like go into more depth in research are the neuroscientists. They will really have to study more in depth with the quantum physics and those who are anesthesiologists. So I want to play a video that I found that helps support this argument a little bit better. All right, so I want to play a video real fast that kind of helps support the argument and kind of shows where this article is going. Dang. Some people think that consciousness is very subjective. Some people think that consciousness doesn't exist. But it is a strong possibility that it actually exists because it's basically some form of awakening, right? Or awareness going on. So otherwise, we wouldn't have some type of awareness if consciousness did not exist. So I'm just going to go ahead and play the video.
How and why are we conscious of ourselves and our surroundings? A lot of research into the subject has been quasi-scientific, spiritual, or metaphysical. But researchers are now searching full bore for a scientific basis for consciousness. Ted Robbins tonight tells us about one researcher following an international conference on consciousness here in Tucson.
Consciousness is defined as the state of awareness of one's existence, thoughts, feelings, and surroundings. We all take breaks from consciousness in benign ways, such as a nap, or in less benign ways, abusing drugs or alcohol. But generally, a high state of consciousness defines us as beings. Stuart Hameroff is an anesthesiologist at University Medical Center in Tucson, who is also one of the world's leading researchers into the nature of consciousness. His research and his associates is moving into an area that may eventually incorporate the physical with the metaphysical.
I think that in the next decades, quantum physics with knowledge of structure within the brain is going to take us on the verge of a reconciliation of spirituality and science that's never been experienced before, and it's going to be really amazing.
In his research, Stuart Hameroff found the physical structures that may govern our consciousness. Most people know the brain is made up of billions of neurons, nerve cells. The neurons transmit information to one another chemically and electrically across a tiny space called the synapse, shown in this drawing. That's where classical neuroscience stopped, but Stuart Hameroff looked closer. What he found within the structure of a single neuron were thousands of cells called microtubules. Looking even closer, he saw the walls of the microtubules are made up of individual proteins, and within each protein, a single electron moves back and forth. One of the ways to study consciousness is to see what the brain does when it's unconscious. When a patient is given a high enough concentration of anesthetic, the anesthetic molecule, with an A in it, binds to the electron and stops it from moving, suppressing consciousness. Remove the anesthetic and consciousness returns. Put billions of these cells into billions of neurons and you have a brain, and not just a computer with its binary on-off switches.
There are a lot of things that the brain does that appear to require much more information processing capability than the 100 billion neurons hooked up to each other. Walking into a room and recognizing a scene instantly. People have tried to simulate that on computers, and it requires near infinitely more computing processing than the number of neurons in the brain. There must be something going on at a deeper level to understand consciousness.
This is the realm of quantum physics. And though science may be able to explain how an atom works, it still cannot explain why all those working atoms give rise to thoughts, feelings, and actions, a person's sense of self.
After a baseball is built up out of atoms. It's built out of molecules. So if you would think that if you knew how all the little bits behave, you should understand how the big thing behaves. But there's a sort of subtle thing in between, which is really not understood in present-day physics. How you go from the small scale to the big scale, and it's a big mystery.
Oxford University's Roger Penrose is one of the world's foremost physicists. He's studied black holes, gravitational fields, and the origins of the universe. Now he is turning his attention inward. What Penrose says is necessary to understand consciousness is a new way of thinking about it.
Present physics, the quantum level and the classical level, they don't fit properly together. You need some radical new view of what's going on. And that radical new view has to have a relevance on the way how our brains work. And it's hard to say at the moment because we don't have that view yet. We will need a major revolution in physics.
Consider something called quantum coherence. Remember those individual electrons moving back and forth? Well, what if for some reason they started moving together? We would have a thought, a feeling, an action.
When a critical degree of coherence is reached, it's like being in one state. This can explain the fact that even though we have billions of neurons, hundreds of billions of neurons, we have one mind, one self, one sense of who we are, rather than neuronal firing all throughout our brain, having competing ideas and competing senses of selves. So this binding together, which is also extended in quantum physics to things throughout the universe even, and has some implications for spirituality and interconnectedness and oneness throughout the universe, within our own brains, these aspects of quantum coherence, of this interconnectedness, gives us one sense of self, of who we are.
What we don't yet know is how quantum coherence happens. Meanwhile, David Chalmers is not so sure knowing how will explain why we think and feel.
These lead to great explanations of behavioral functions, our ability to make reports of our mental states, our ability to respond to situations in the environment, and so on. What these explanations don't tell us is why all this information processing should be accompanied by a subject that experiences all this information content. And that's the really key problem of consciousness to me.
In other words, why are we doing it? Why is the mechanism of our body?
Right. Why is that mechanism accompanied by an inner life, if you like? It's the inner life that's really the mysterious aspect of consciousness.
I think consciousness emerges in evolution at a critical level of complexity of organisms. I think it emerges every day as we wake up. It emerges in our patients waking up from anesthesia. It emerges in the growth of a baby or maybe even a fetus. It emerges and eventually assumes control over the organism. So it's not merely along for the ride. It's actually running the show, I believe, and most people believe, although there are others who feel the opposite. Why it's there, that's a good question.
And why study consciousness? Well, perhaps to paraphrase what Einstein said, because all science is really a search for God.
In quantum theory, we find these behind-the-scenes influences that are unseen but definitely felt, often subtle, sometimes powerful, that when we observe them often seem to be random, to have no rhyme or reason. But in other situations, do seem to have a sense of laws, of purpose, of organization. And that's a pretty good explanation for God or spirituality.
All right. So again, the reason why I really agree And as you heard the anesthesiologist, Stuart Hemmerhoff, he explains it the best. Like, we have some type of consciousness when we wake up in the morning, and like we have consciousness when we come off the anesthesia, and even babies have some form of consciousness. Now, there might be levels to consciousness as far as how is as far as like how one goes about dealing with it, but or consciousness is not operate on the same level. Let's put it like that. You know what I'm saying? But what they have in common is some form of awareness, a sense of awareness. Now, one may not be able to respond to everything like someone else. Like for example, an infant may not be able to open their mouth and speak and say what's going on with them, but you can tell that there is some type of awareness with them. How? Because once they start crying and once they're starting like having some type of motion, when they move around, they kind of know that, okay, they're somewhere that's outside of the environment they was in. So once they come out their mother's womb, they know that they start to realize, okay, I'm no longer in the womb. So they just start to get their first taste of life, right? They start taking their first breath. They start being able to move around, move their arms, move their legs, and things like that. So, yeah, so consciousness is done on different levels. Now, I have some information that I would like to present. So I got some information from the very same article that I was reading earlier. And it says like this. It says, our brains are composed of cells called neurons, and their combined activity is believed to generate consciousness. Each neuron contains microtubes which transport substance to different parts of the cell. The Penrose and Hameroff theory of quantum consciousness argue that microtubes are structured in a fractal patterns which would enable quantum process to occur. So fractals are structures that are neither two-dimensional or three-dimensional, right? But are instead some fractal value in between. In mathematics, fractals emerge as beautiful patterns that repeat themselves infinitely, generating what is seemingly impossible, a structure that has a finite area but an infinite perimeter. So that's something I read earlier coming from the article. All right. And so again, it all goes back to the neurons. And so, I mean, without the neurons, how would you be able to function? How would one be able to function if they don't have the neurons? Also, there's a theory that I want to show. And this theory is called the orchestrated objective reduction. All right, so, and as you can see, this is Dr. Roger Penrose. That's Dr. Roger Penrose. So now, going on further, it says it's a controversial hypothesis that postulates that consciousness originates at the quantum level inside neurons, rather than the conventional view that it is a product of connection between neurons. The mechanism is held to be a conscious process. A quantum process called objective reduction that is orchestrated by cellular structures called microtubules, right? It is proposed that the theory may answer the hard problem of consciousness and provide a mechanism for free will. The hypothesis was first put forward in the early 1990s by Nobel laureate for physics Roger Penrose and anesthesiologist and psychologist Stuart Hemmerhoff. The hypothesis combined approaches from molecular biology, neuroscience, pharmacology, philosophy, quantum information theory, and quantum gravity. So now, let's look at the background. All right, now going down here where it says the background, it says in 1931, mathematician and logician Kurt Gödel proved that effectively generated theory capable of proving basic arithmetic cannot be both consistent and complete. In other words, a mathematically sound theory lacks the means to prove itself. An analogous statement has been used to show that humans are subject to the same limits as machines. However, in his first book on consciousness, The Emperor's New Mind, 1989, Roger Penrose argued that Gödel's unprovable results are provable by human mathematicians. He takes this disparity to mean that human mathematicians are not describable as formal proof systems and are therefore running a non-computable algorithm. All right. So it goes on to say, if correct, the Penrose-Lucas argument leaves the question of the physical basis of non-computable behavior opening. Most physical laws are computable and thus algorithmic. However, Penrose determined the wave function collapse was a prime candidate for a non-computable process. So in quantum mechanics, particles are treated differently from the objects of classical mechanics. Particles are described by wave function that evolve according to Schrödinger equation. Non-stationary wave functions are a linear combination of the is it ingenestates of the system, a phenomenon described by the superposition principle when a quantum system interact with a classical system, i.e., when an observable is measured, the system appears to collapse to a random eigenstate of the observable from a classical vantage point. Now, and as you can see, there's the equation at the very bottom. Now, let's look at the criticism they received. But before I go there about the criticism, I just want to say this. To me, it would be a combination of both quantum physics and theoretical physics, because theoretical physics dealing with the prediction, right? And a prediction of a natural phenomenon, pretty much. So, however, I don't really want to conflate the two like that, but that's just how I feel, because I see that as a combination of both quantum physics and theoretical physics, being able to try to explain the neuroscientific concept of consciousness. And I think it's a good thing it is done that way versus just doing it in just a spirituality or in a new age, in a new age way, because it's one thing to have new age, because new age can just solely operate off of belief and not really bring so much not bring so much verifiable sources, or not bring enough information or consensus to present a good argument. It's just based off the concept of spirituality and God, which is really nothing wrong with that, I mean, especially if you're a pantheist, there's nothing wrong with it, because that would be the best way to see it. However, when it comes to scientific research on things like the connection with quantum physics and consciousness, it would have to be consist of ongoing research. It would have to consist of trial and error, falsibility, things of that nature. You would have to be able to show and prove. So far, it's just a hypothesis, but there are scientists that try to debunk this and say, oh, that's not conclusive. It's not a argument, but it would take a lot of study to actually agree or to disagree or to approve or disprove the claims. So again, there's a lot of logic to the argument. I mean, it's very logical. You just can't. I mean, especially on the anesthesiologist end, which is Stuart Hammeroff. I mean, he has a better argument. He has a stronger argument, because he's able to study, by him being an anesthesiologist and being able to study how people brains are functioning when they go into a deep sleep. He has a better argument. He has a better point of view. So, all right, so down here's the criticism. It says, Arch OR has been criticized both by physicists and neuroscientists who consider it to be a poor model of brain physiology. Arch OR has also been criticized for lacking explanatory power. The philosopher Patricia Churchland wrote, "Pixie dust in the synapses is about as explanatorily powerful as quantum coherence in the microtubules." Decoherence in living organism. So one person put in 2000, Max Tegmark claimed that any quantum coherent system in the brain would undergo effective wave function collapse due to environment interaction long before it could influence neural process. The warm, wet, and noisy argument as it was later came to be known. He determined the decoherent time scale of microtubule entanglement at brain temperature to be on the order of, was it femtoseconds, far to believe for neural process. So Christoph Koch and Klaus Help also agreed that the quantum coherence does not play or does not need to play any major role in neurophysiology. All right, so let's look at what quantum coherence is. Now, quantum coherence, according to quantum mechanics, our objects can have wave-like properties. Okay. For instance, in Young's double slit experiment, electrons can be used in the place of light waves. Each electron's wave function goes through both slits and hence have two separate split beams that contribute to the intensity pattern on a screen. According to the standards wave theory, these two contributions give rise to an intensity pattern of bright bands due to constructive interference interlaced with dark bands due to destructive interference on a downstream screen. This ability to interfere and diffract is related to coherence, classical or quantum, of the waves produced at both slits. The association of an electron with a wave is unique to quantum theory. So, now going back to where it says electrons can be used in the place of light waves, right? Then the question is, how can quantum coherence not be useful in this argument? I mean, because if electron can be used in light waves and the particle can have some type of wavy movement going on, then why it would not be useful? Why would that be debunked? So again, it will be something that has to be an ongoing research before one can say that, oh, it's not a logical argument. So to me, I think that, with the quantum coherence and you got the quantum physics and the neurons and fractals, right, and bioelectromagnetism, that can help. These things pretty much bring a correlation between quantum physics and consciousness combined together. And that's just how I see it. So you guys just give me a second. All right, so let's take a look at what's the other guy's name, David Chandler's argument regarding to this. So I want to look at some sources that he So yeah, I want to look at some of the sources that he had used for his argument. So let's look up David Chandler. All right, so let's look at who David Chandler is real quick. All right. So David Chandler. David Chandler is an Australian philosopher and cognitive scientist, specializing in the area of philosophy of mind and philosophy of language. He is a professor of philosophy and neuroscience at New York University, as well as a co-director of NYU Center for Mind, Brain, and Consciousness. In 2013, he was elected a fellow of the American Academy of Arts and Science. Okay, so he is best known for formulating the hard problem of consciousness and the philosophical zombie through experiment. He is the co-founder of Philip Papers, a database of journal articles for professionals and students in philosophy, along with David Brigade. All right, so let's go down to where it says his career. So in 1994, Chambers presented a lecture at the inaugural Towards a Science of Consciousness conference. According to an article in Chronicles of Higher Education, this lecture established Chambers as a thinker to be reckoned with, a goose a nascent field into greater prominence. He went on to co-organize the conference, and which is now the Science of Consciousness. For some years with Stuart Hameroff, but stepped away when it became too divergent from mainstream science. Chambers is also a founder member of the Association for the Scientific Study of Consciousness. All right, so let's see. It says here that in 1996, while teaching, he published the widely cited book, The Conscious Mind. All right. So let's look at his philosophical work. So he goes into the concept about the philosophy of mind. So Chandler is best known for formulating what he's called the hard problem of consciousness in both his 1995 paper, Face Up to the Problem of Consciousness, and his 1996 book, The Conscious Mind. He makes a distinction between easy problem of consciousness, such as explain object discrimination or verbal reports, and the single hard problem, which could be stated, why does the feeling which accompanies awareness of sensory information exist at all? The essential difference between the cognitive easy problem and the phenomenal hard problem is that the former are at least theoretically answerable via the dominant strategy in the philosophy of mind, physicalism. And Chambers argues for an explanatory gap from the objective to the subjective, and criticizes physicalist explanation of mental experience, making him a dualist. Chambers characterized his view as naturalistic dualism. Naturalistic because he believes mental state supervene naturally on physical systems such as brain. Dualist because he believes mental state are ontologically distinct from and not reducible to the physical system. He has also characterized his view by more traditional formulations such as property dualism. All right, so let's look at what is naturalistic. All right, so just so I can be able to convey this point. So in philosophy, naturalism is the idea or beliefs that only natural laws and forces, as opposed to natural, supernatural, or spiritual ones, operate in the universe. And adherents of naturalism assert that natural laws are the only rules that govern the structure and behavior of the natural world, and that the changing universe is at every stage a product of these laws. All right. So that's naturalism. Okay. And let's look at property dualism. So property dualism describes a category of position in the philosophy of mind, which holds that although the world is composed of just one kind of substance, the physical kind, there exists two distinct kind of property, physical property and mental properties. In other words, it is the view that the non-physical mental properties, such as thoughts, imagination, and memory, exist in or naturally supervene upon certain physical substance, namely brains. Okay. So now, going back to this, he's very interesting. I never really actually read his work, to be honest. But it seemed like he has an interesting argument. He really has an interesting argument as far as dualism is concerned. That's the best way to be, because there is some form of natural laws, or what we call the natural laws, that the universe follows, and not only what the universe follows, but also, as far as like just organism and all of that. So it's some form of natural laws that take place, that exist. So which is why, that's another reason why I believe that quantum physics is in correlation with consciousness through natural laws. So let's look at what the natural laws is. I know there's a lot of information I'm posting up, but I have to really go into this to actually explain my argument, where I stand. So let's look at natural laws. Okay, so it's a system of law based on a close observation of human nature and based on values intrinsic to human nature that can be deduced and applied independent of positive law. All right. So according to natural law theory, all people have inherent rights conferred not by an act of legislation, but by God, nature, or reason. Natural law theory can also refer to theories of ethics, theories of politics, theory of civic law, and theories of religious morality. Okay. So again, you acting in forces with nature. So if you're acting in force with nature, then it's like nature is doing it's like nature doing its work. So the fact that nature is doing its work, we may not fully understand what it is, but it's there. You know what I'm saying? It's there. So what I'm trying to get at is, we can't sit here and say that, oh, quantum physics doesn't have anything to do with consciousness if we don't really have enough understanding, or if we have not studied into more details. Like we cannot sit here and say that there is no type of correlation, or it doesn't exist with one another. It doesn't have any type of relationship. We can't make that argument. We can't, because because at the end of the day, that's when you really have to prove, what do you mean that there is no type of relationship? So, because we really don't know enough as humans to really like give an accurate point as far as saying regard to quantum physics and consciousness and the neurons, etc. We can't make the argument. We don't have enough information to say, oh, this doesn't work out, because again, it's still an ongoing research. So it's more so of maybe not. It could be a possibility. So that's something that has to be dealt with a lot of study. So like I said, I do believe in quantum coherence. I do believe that there is a natural law. I also believe that, the photons and the neurons and the radicals and all of that plays a factor into bringing about those correlation. Okay, let me see. The universe follows natural laws and quantum rules, maybe, huh? Maybe. I believe it do. I believe that the universe has a law that it follows. We call it the natural laws, but it may not be the laws per se. It's just how the universe naturally operates. You see what I'm saying? I hope that makes sense. I mean, it both can work together, as far as like how the quantum and natural law, I think they both work in conjunction with each other, in my opinion. So, yep. For me, it's very let's see what it says. The camera on the citizen of New York City affected the behavior of the citizen. I'm not sure where you're getting at. I don't know if you using that as an example as far as the camera on the citizen of New York City affected the behavior of the citizen. But then again, let's just go with that example that you put out there. Some people can be affected as far as like their behavior. Some people might react to being on camera and try to turn away, and then some people just simply ignore the camera being around them, and then some people just be very joyful and just act out, doing little belligerent stuff, or just get playful and have fun, etc. Okay, quantum comparison. Okay, gotcha. Cool, gotcha. So yeah, I mean, we can go with that example because it depends on the individual. Some individuals would ignore the camera being in front of their faces, and some individual would just be delighted that they're on camera and they'll just act out. And then there are some individuals where they try to get away from being on camera. They'll try to turn the opposite direction. So again, it depends on the individual's behavior. Everybody don't behave the same way. Okay, I understand you a lot better now. I get what you're saying. Quantum comparison, cool. Yeah. But yeah, just getting at it, we just don't really know enough to really say that, there's not, this doesn't take place or that doesn't take place. Now, there's certain things that can bring about answers, but then there's those that it just require an ongoing research. And this happens to be one of the subjects that requires an ongoing research. Okay. So let's see. I'm gonna put something in the chat if you guys want to come on here and give your thoughts or whatever. So anyways, let me just go ahead and go to the next thing. See, it says now on the quantum level, the electrons straighten up and go through the two slits. Now, yes, I did read the information about that. Yep. So now the question becomes, do we not have these particles in us? Are we not made of protons, neutrons, and electrons? Are we not made of those particles? Are we not made of any type of subatomic particles? Does it not operate within us? That's the question. Now that you have said that, now the quantum level, the electrons straighten up and go through the two slits. Now that you said that, could it be logical that these two things does take place as far as the relationship between quantum physics and consciousness? When the camera is on, the electrons only. When the camera is on, the electrons only. Well, I guess you're saying that because it produces light. Yeah. Because at this time you're dealing with the photons, right? But let me post that article back up again. So for anybody that wants to look at this article, and that's the title of the article. Can consciousness be explained by quantum physics? Fascinating research takes us a step closer to finding out. All right. All right, so let's see. I have some sources that you guys also can check out. Some more sources. Let's see. The electrons only go through two slits when the camera is on. Okay. Okay. Now, again, let's go back to the question. I get what you're saying about the camera, right? Now let's go to the question. What about the electron when it's operating within the human's brain? When it's dealing with the neurons? Because again, remember, we are made of atoms, right? And we're made of subatomic particles, right? So now let's take that same argument that you just made, Philip, and let's just bring it into the concept about go to YouTube double slit theory cartoon. All right, let me go ahead and look that up right now while I'm here. Give me a second. Let me look that up right now. But yeah, just think about the question I just asked, if you can. Okay. So I'm about to go ahead and post the video that Phyllis was talking about, the double slit theory cartoon. Double slit theory. Okay, so let me go ahead and post up this cartoon right here. Oh, you didn't hear the question? Okay, so the question I was asking, right? When you said the electrons only go through two slits with the camera on. Now, let's put the concept of electrons inside the human's brain, right? Because remember, we're made of atoms, correct? If we're made of atoms and we're made of subatomic particles, right? If we have proton, neutron, and electrons within us, right? Let's just put that in the concept of the brain. How does the electron operate within the brain? Does it still have a two slit, or there is no two slit when it comes to the brain? So hopefully my question makes sense. All right, but I'm gonna post that video that you're talking about though. Hold on, give me a second. Let me go ahead and post this video up.
And here we are, the granddaddy of all quantum weirdness, the infamous double slit experiment. To understand this experiment, we first need to see how particles, or little balls of matter, act. If we randomly shoot a small object, say a marble, at the screen, we see a pattern on the back wall where they went through the slit and hit. Now, if we add a second slit, we would expect to see a second band duplicated to the right. Now, let's look at waves. The waves hit the slit and radiate out, striking the back wall with the most intensity directly in line with the slit. The line of brightness on the back screen shows that intensity. This is similar to the line the marbles make. But when we add the second slit, something different happens. If the top of one wave meets the bottom of another wave, they cancel each other out. So now there is an interference pattern on the back wall. Places where the two tops meet are the highest intensity, the bright lines, and where they cancel, there is nothing. So when we throw things, that is matter, through two slits, we get this, two bands of hits. And with waves, we get an interference pattern of many bands. Good so far. Now, let's go quantum. An electron is a tiny, tiny bit of matter, like a tiny marble. Let's fire a stream through one slit. It behaves just like the marble, a single band. So, if we shoot these tiny bits through two slits, we should get, like the marbles, two bands. What? An interference pattern. We fired electrons, tiny bits of matter through. But we get a pattern like waves, not like little marbles. How? How could pieces of matter create an interference pattern like a wave? It doesn't make sense. But physicists are clever. They thought, maybe those little balls are bouncing off each other and creating that pattern. So they decide to shoot electrons through one at a time. There is no way they could interfere with each other. But after an hour of this, the same interference pattern is seen to emerge. The conclusion is inescapable. The single electron leaves as a particle, becomes a wave of potentials, goes through both slits, and interferes with itself to hit the wall like a particle. But mathematically, it's even stranger. It goes through both slits and it goes through neither. And it goes through just one and it goes through just the other. All of these possibilities are in superposition with each other. But physicists were completely baffled by this. So they decided to peek and see which slit actually goes through. They put a measuring device by one slit to see which one it went through and let it fly. But the quantum world is far more mysterious than they could have imagined. When they observed, the electron went back to behaving like a little marble. It produced a pattern of two bands, not an interference pattern of many. The very act of measuring or observing which slit it went through meant it only went through one, not both. The electron decided to act differently, as though it was aware it was being watched. And it was here that physicists stepped forever into the strange, never world of quantum events. What is matter? Marbles or waves? And waves of what? And what does an observer have to do with any of this? The observer collapsed the wave function simply by observing.
Okay, so now with that video being said, isn't that kind of going into the details that I was stating before? Now, when it showed and proved that the electrons, right, go through a slit. Now, it was said to be in the beginning, people thought the electron goes into a two slit, right? But it actually go into one slit. Now, does that conclude the argument? Trippy, huh? I mean, the information, yeah, it just kind of like, because I feel like the information kind of goes into what I'm talking about, but it explains it differently. So, like, especially when it talks about how the electron goes into the slit and it kind of bounce back and go into its very particle state, etc. I mean, wouldn't that be the same way? Like, let's say if a person goes into anesthesia, right? And they're under, you know, when you're under anesthesia, of course, you're in a deep sleep and all of that, right? I mean, wouldn't it be fair to say that the electrons move in that same direction when a person is on anesthesia? I mean, think about it. If you're in a deep sleep, right, your body is not moving, but your brain is moving. So if your brain is still in motion, right, and all the particles that's in your brain and all the cells that's taking place, can it be safe to say that the electron is doing exactly the same thing in your brain as is demonstrated in this video? Can it be safe to say that? Can it be safe to make that same argument that the electron that creates a split, right, and it bounces back, and it does the same thing inside your brain when you're under anesthesia or when you're asleep, or let's say when you're meditating? Can we say that it's the same argument? And I'm asking Phillips. So hopefully if Phillips got my question, I'm just waiting for him to respond. Let's see. Let me see something. Now, it acts different when the camera is present. How did the electron know the camera was there? Well, obviously, it had to be through the photons. I mean, if the electron knows that the camera is there, it had to be through the photon, because the photon deals with what? Some form of light. So it gave some form of signal to the electrons that, okay, that the camera is there because of photon or some type of radiation. That would be my answer. All right. So let's see. I'm trying to get through y'all comments. It says the electrons are running into other electrons. You are acting like if there is no electrons. No, nobody. No, you totally missed the argument. No, you totally missed the argument. Nobody said that, sir. See, you totally missed that. Nobody's saying that there is no electrons, no electron in space. Nobody's saying that. But if you're going to talk about electrons, you got to talk about radiation, because it's radiation that gives off these lights for the electronics to happen. So we're not saying that that electrons don't run into other electrons, but I'm just speaking as far as the brain is concerned, right? If you go into a deep sleep, or let's say you're meditating, or you're on anesthesia, and the only thing that's still moving is your brain, right? The neurons and all of that, the cells and stuff like that, everything is in motion. The question I ask is, the question I ask is, would the electron do exactly the same thing that it's doing to the camera? Wouldn't it do that inside your brain? Let's see. The electrons are going into a wave pattern. It's not a single pattern as it looks. Okay. Now, you made that argument. You said the electrons are going into a wave pattern. Now, with that being the argument that you made, can't you say that the electron also have a wave pattern in your brain? Now, do your brain not have a wave pattern? Does the brain not have a wave pattern? Yes or no? And if it does have a wave patterns, if it does have a wave pattern, if it does, what that means that the electron is operating, correct? Because what we're trying to do is, right, we're trying to, bring the argument about the relationship between quantum physics and consciousness. Let me see. I wish I could get y'all on here to talk. I put the link up there. I guess some of y'all is not comfortable with being on camera, and that's okay. I understand. The scientists have not figured it out yet. See, that's the thing. Now, since the scientists have not figured out, how can the scientists then turn around and debunk Penrose and what's the other guy's name? Oh my God, his name was just in my head. Hold on, give me a second. Let me go to my notes. Yeah. If scientists have not figured it out yet, how can they then debunk Penrose and Hameroff theory about quantum coherence and quantum consciousness? How can they debunk the argument? How can they then debunk those arguments if scientists have not yet figured it out? So therefore, it's still an ongoing research. It would do the same inside your brain if you are under anesthesia. It just double your nerves. Okay, bingo. It just double your nerves that is attached to your brain. It does not do the brain. The brain is fully functioning still. Okay, the argument now, you made a good point right there. Yes, we know that the brain is still functioning. But you as a person, when you under anesthesia, you're asleep. You can't move around because you're in a deep sleep, right? But your brain is still functioning. Now, with that argument that you made, it would do the same thing inside your brain if you are under anesthesia. It would just double your nerves. So therefore, we can make the argument that is a strong possibility that there is the correlation between quantum physics and consciousness, correct? Based off of your argument alone, Snuggle 668, based off your argument alone, can we make that same? Can we say that there is a strong possibility that quantum physics has some type of correlation to consciousness, based on what you just said? Okay, so it says, what word did they use to debunk it? They have the word hypothesis. Okay, hold on. Let me go back to the source. I need to get my weight up on metaphysics too. I mean, yeah. Oh, yeah. Metaphysics is important. Yeah, it's important as well to study metaphysics. But let me go ahead and get the yeah, I gotta study more in depth into metaphysics too, because metaphysics is kind of like it's a philosophical subject because of course it deals with philosophy, but it's kind of like a tricky subject. It's kind of like a complicated subject to study, if that makes sense. Because there's two different types of metaphysics, but one of the metaphysics deals with the new age, and the other metaphysics deal with just strictly philosophy. But let me go back to the source that I had before. Okay. Let's go back to the source. Let's go back to the criticism that they received. So let's go down here to where it says criticism. And I'm about to put up the source real fast. Hold on. I'm about to put up the source real fast. Just give me a second. All right. So now it says criticism. Now the theory is called the orchestrated objective reduction. Okay. Now going down to where the criticism is, it says it has been criticized by both physicists and neuroscientists who consider it to be a poor model of brain physiology. All right. So the orchestrated objective theory has been also criticized for lacking explanatory power. The philosopher Patricia Churchland wrote, "Pissy thus in the synopsis is about as explanatorily powerful as quantum coherence in the microtubules." So now, how can they say that it is poor? It's a poor model of the brain physiology when they have yet to really figure out and done the research on the brain to even give that type of criticism. Now let's look at quantum coherence. Okay. Oh, well, as a matter of fact, let's go down here. It says in 2000, Max Tegmark claimed that any quantum coherent system in the brain would undergo effective wave function collapse due to environmental interaction long before it could influence neural process, the warm, wet, nosy argument as it was later to be known. He determined the decoherence timescale of microtubule entanglement at brain temperatures to be on the order of femtoseconds, far too brief for a neural process. And then also there's another criticism by Christoph Koch and Klaus Help also agreed that quantum coherence does not play or does not need to play any major role in neurophysiology. Where am I at? Okay, Koch and Help concluded that the empirical demonstration of slowly decoherent and controllable quantum bits in neurons connected by electrical or chemical synapses or the discovery of an effective quantum algorithm for computation performed by the brain would do much to bring these speculation from the far out to the very unlikely. Now, again, if they have not studied enough information about this, how can they then make this type of argument? That's just what I'm trying to get. If you say that quantum coherence does not play or does not need to play a major role in neurophysiology, then where is the proof that it does not need to play a role? How can't you say that? That's where I'm trying to get at. How can the argument be said that the quantum coherence does not need to play a role? Again, you don't have enough information to actually prove that. So you're just basically speculating, right? I know I'm all over the place, but I hope y'all understand what I'm saying. Let's see. I agree quantum physics and consciousness, I think, is one of the same because everything uses electricity or some form of electrons, protons, neutrons. Yes, we all use some form of, I wouldn't say it's the same because consciousness is something different from quantum physics. I would say that quantum physics helps enhance consciousness. That's why I think that quantum physics enhance consciousness, but I would not say that it's the same because quantum physics is like really just dealing with the mathematical aspect of the physical property of the subatomic particle and study the behaviors and stuff like that. But I would not say that it's the same thing as consciousness. I would just say it enhances consciousness. It better helps explain consciousness, in my opinion. But again, that would still be an ongoing research. All right, so and it goes on to say, somebody said too brief for a neural process. That's the slip. How is it too brief? My comment came from what you just finished reading. I just feel like it's not enough to even make the argument that that the quantum coherence should not have anything to do with consciousness. Like, I don't think that's enough argument. I think that's just a speculation because even then that would still require to like do the ongoing study research to actually debunk it. That's where the trial and error has to come into place. I know I sound a little scientific, but I'm not a scientist. I just like studying quantum physics, and I'm still trying to understand more about it. But so far, I'm getting enough understanding to where I can come up with my own views about this and whatnot, as far as like the correlation between quantum physics and consciousness. So I would just only like explain my position. I was supposed to have somebody else on here tonight. Obviously, they did not show up, so I don't know what's going on, but I'm here. All right, so I have a book that you guys can look at. Oops. I hope you guys can see it. Okay, cool. All right, so the title of this book is called Consciousness and the Universe. So Quantum Physics, Evolution, Brain, and Mind. And it was written by Sir Roger Penrose, Stuart Hameroff, and Shahaz Khan. So if you guys don't have this book, I recommend get this book. As a matter of fact, let's look into this book real fast, just really fast. All right, so I ain't gonna really go into all of it, but I just want to look into this. Let's look at consciousness in the universe, neuroscience, quantum space-time geometry, and arch OR theory. Okay, so let's look at chapter 1. So right down here, as you can see, it says abstracts, and of course, it got the name of the authors and the universities, and etc. All right, so under abstract, it says the nature of consciousness, its occurrence in the brain, and its ultimate place in the universe are unknown. We proposed in the mid-1990s that consciousness depend on biologically orchestrated quantum computation and collection of microtubules with brain neurons, that these quantum computation correlate with and regulate neuronal activity, and that continuous Schrodinger evolution of each quantum computation terminates in accordance with specific Dose-Penrose scheme of objective reduction of the quantum state. This orchestrated RR activity is taken to result in a moment of conscious awareness or choice. This particular form of OR is taken to be a quantum gravity process related to the fundamentals of space-time geometry. All right. So arch OR suggests a connection between brain biomolecular process and fine scale structure of the universe. Here we review and update arch OR in light of criticism and developments in quantum biology, neuroscience, physics, and cosmology. And a lot of people don't know this. People don't know that cosmology is also considered as philosophy, as well as actually cosmology is also considered as a branch of metaphysics. And I can show you proof. So yeah, a lot of people don't know that cosmology is also considered as a branch of metaphysics. Isn't that interesting? As a matter of fact, if you don't believe me, I got proof. All right, hold on. Let me show y'all proof, because I don't want nobody thinking that I'm just making up stuff. All right, so right here, where it says branches of metaphysics, cosmology, a central branch of metaphysics that studies the origin, fundamental structure, nature, and dynamics of the universe. And of course, and it goes into different level of cosmology. You got the physical cosmology, a Big Bang cosmology, non-standard cosmology, plasma cosmology, right? And then of course it gets into the religious aspect of cosmology, and esoteric cosmology. All right, but let's look at these first four. So physical cosmology, the study of the largest scale structures and dynamics of the universe, and is concerned with fundamental questions about its formation, evolution, and ultimate fate. The Big Bang cosmology based on the Big Bang model of the universe. The Big Bang is a theoretical explosion from which all matter in the universe is alleged to have originated approximately 3.799 plus billion years ago. Non-standard cosmology, any physical cosmological model of the universe that has been or still is proposed as alternative to the Big Bang model of standard physical cosmology. And plasma cosmology, a non-standard cosmology whose central postulate is that the dynamics of ionizing gases and plasma rather than gravity play the dominant roles in the formation, development, and evolution of astronomical bodies and large-scale structure in the universe. So yeah, there it goes. But yeah, it's considered as being a branch of metaphysics. Yep. Yes, sir. Let me see. Word, because the so-called scientists are guessing as well. That's all they can do is guess, because they don't have a definite answer. So in science, what people got to understand, science does not give a definite answer to everything. It's an ongoing research. So, and especially when it comes to modern eras, right? When we in by us being in the modern era in different time period, things are going to be upgraded. So when things are going to be upgraded, technology is going to be upgraded, and then that means information got to be upgraded. So yes, they're going to take a guess because they don't really have a lot of answers. And consciousness is not easy to explain. You know what I'm saying? That's still ongoing research about consciousness. So, and even quantum physics, and what I found out, even those who are physicists, they don't really know how to explain quantum physics, because quantum physics is more like that mystery science. Okay, it's closely related to theoretical physics in a sense. So it's like that mystery science. It's like that science you trying to really understand, but you can't really understand because it's very complex. Yep. The quest for knowledge continues. You're right, my friend. Space-time geometry sound interesting. Yep. And you say ongoing research. Absolutely. Yes, it's an ongoing research. That's all it is. But let's go ahead and get back to the book real fast. All right. All right, then. So back to the book. Okay, so going back to what I was reading, so ARCH OR suggests a connection between brain biomolecular process and fine scale structures of the universe. Here we review and update ARCH OR in light of criticism and development in quantum biology, neuroscience, physics, and cosmology. We conclude that consciousness plays an instrument role in the universe. Keyword consciousness, microtubules, OR, ARCH, OR, quantum computation, and quantum gravity. So now it go down to the introduction, consciousness, brain, and evolution. All right. So I'm going to read down here. Okay. It says consciousness implies awareness, subjective experience of internal and external phenomenal worlds. All right, give me a second, you guys. Sorry about that. Give me 1 second. Okay. All right, so let me go back to what I was reading. Sorry about that. So anyways, it says consciousness implies awareness, subjective experience of internal and external phenomenal worlds. Consciousness is the central also to understanding meaning and volitional choice with the experience of free will. Our views of reality of the universe of ourselves depend on consciousness. Consciousness defines our existence. And it says 3 general possibilities regarding the origin and place of consciousness in the universe have been commonly expressed. A, consciousness is not an independent quality, but arose as a natural evolutionary consequence of the biological adaptation of brains and nervous system. The most popular scientific view is that consciousness emerged as a property of complex biological computation during the course of evolution. Opinions vary as to when, where, and how consciousness appear. Only recent in humans or earlier in lower organisms. Consciousness as evolutionary adaptation is commonly assumed to be epiphenomenal, a secondary effect without independent influence. Through it is frequently argued to confer beneficial advantages to conscious species. Now B, Consciousness is a quality that has always been in the universe. Spiritual and religious approach assume consciousness has been in the universe all along, as the ground of being, creator or component of an omnipresent God. Panpsychists attribute consciousness to all matter. Idealists contend consciousness is all that exists. The material world is an illusion. Precursors of consciousness have always been in the universe. Biology evolved a mechanism to convert conscious precursor to actual consciousness. This is the view implied by Whitehead and taken in the Penrose Hammer-Off theory of orchestrated objective reduction. All right, precursors of consciousness, presumably with proto-experimental qualities, are proposed to exist as the potential ingredients of actual consciousness. The physical basis of these proto-conscious elements not necessarily being part of our current theories of the law of the universe. All right, so I hope you guys grabbed on to that. Okay, now, all right, I'm about to bring somebody on here. Let me see what somebody said. Somebody put, we could break down the breakdown if we give thought to it. Yeah, we could, but again, it would be a lot. See, it's a lot of information to process, and by it being a lot of information to process, then you have to be able to process the information, how to go about how to break it down in its simplistic form, you know. And Ngozi, are you there?
Yeah, I'm right here, sister. Peace and love.
Peace, 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 peace. Okay, so I know you came very, very late. I know you was busy and whatnot. So basically, you know, the topic about the whole quantum physics and showing the relationship with consciousness. So there was an article that I have posted that shows that scientists are trying to, I guess they are close to finding the answers as if does quantum physics have something to do with consciousness as far as the correlation is concerned. And I basically just proved that, you know, I support the argument because, as a matter of fact, I can read some of the information to you since you just getting in here. So just to get you up to date on what's going on. So the information, the title of the article is called "Can Consciousness Be Explained by Quantum Physics?" by ScienceTechDaily.com. All right, and it came out August the 2nd of 2021. It says our brain are composed of cells called neurons, and their combined activity is believed to generate consciousness. Each neuron contains microtubules, which transport substance to different parts of the cell. The Penrose and Hammer-Off theory of quantum consciousness argues that microtubules are structured in a fractal pattern, which would enable quantum process to occur. Fractals are structures that are neither two-dimensional nor three-dimensional, but are instead some fractional value in between. In mathematics, fractals emerge as beautiful patterns that repeat themselves infinitely, generating what is seemingly impossible, a structure that has a finite area but an infinite perimeter. Okay, so
That's Stuart Harford, if I'm not mistaken. And consciousness does exist beneath the microtubules. Microtubules in layman's terms are the small skeletoids of the cells at root, or skeletal structures of the cells. So yes, quantum. If you go below that, the quantum particles is the predecessor of all mass. It's the medium between all mass at root. What I mean is, if you go, and it's easy for him to say that, you know, but below the cellular structure, the neuron, which is the electrical cells, and you go below that into the microtubules, which is the skeletoids of the cells, or the structure.
Ngozi?
We went through this before. It's the super subatomic to the atomic to the molecular. And molecules is a collection of atoms, to DNA, RNA, and cell. So at root, quantum particles is always around us. Primarily those 6 flavors of quantum particles, which is the quarks moving up, down, charm, strange, top and bottom. Top and bottom is the ones that's responsible for everything. Even if you go into the periodic table, below every the more protons you have, the more the elements change. And each element change within all those protons and neutrons and electrons that makes up each element itself. You have quarks at the core of it. So quantum particles is at the root of everything. Now, to go back to the term consciousness or awareness, there's always a sense of awareness. But how do we explain what awareness is at root? Because for me, because reality decays and is subject to change, I ultimately believe that the universe, in a visible reality that's subjective but made out objectively, is an illusion. To me.
Oh, okay. To
me.
Okay. Got you.
And the reason why I say that is because I can't explain what awareness is, but awareness is what it is. So I like, for example, existence. I mean, for example, I'm aware. But how much of awareness am I aware of being the character that I am now? Because there's a lot of activity going on at the quantum level that can't be measured right now. You get what I'm saying? The behavior of quantum particles can't be measured. What level of consciousness or awareness is that within itself? Dealing with quantum particles is, but I do agree with Stewart. I do agree with him with consciousness existing at the core of the microtubulars at the small scale. I do believe that consciousness plays a major role in that. But I believe consciousness even goes, a form of awareness even goes below that. And even beneath that. You get what I'm trying to say?
Yeah. I get what you're trying to say. I think you're saying that it goes like way below, but we just don't have the answer. We don't, it would take a lot of thorough research to actually find out like how far can consciousness goes.
Yes.
We only know enough that is being presented to us.
Right. But I do believe that physical reality is an illusion.
Okay. Oh, okay. Okay. Now wait. Now I want to ask you something real fast. So somebody posted up something earlier, all right, regarding to the concept about electron. So somebody used an example that the electron only go through the two slit with the camera on. And then they asked the question regarding how does the electron knows that the camera is on. So they're using it as an example as to, help explain the concept of consciousness and stuff like that.
The double slit theory. Uh-huh.
Yeah, the double slit theory. Yeah. So I'm going to ask you the question that I asked this person. Now we know that the double slit theory, right? We know that, okay, the electron, let's just say this is the electron. It's a pin, but let's say it's an electron, right? And the electron is going through that little slit.
Uh-huh.
When it goes through that little slit and it bounces back, right, and going back to its state, okay?
Uh-huh.
So now if it goes back to its state, can we make that same argument that's what it does inside your brain? Like, let's say like when you're under anesthesia or when you're meditating or you just going to sleep or you're in a deep sleep, your body is not really moving, but it's like the neurons and all of that in your brain is moving. It's constantly in motion.
It's static. It's moving. It's activity.
Okay. So now can we make that argument that the same thing that the electron is doing as far as with the camera is concerned, as far as the double slit, is it doing the same thing inside your brain?
If the observer is there, you know about the observation. Who's there to see if it's not an observer? What's the observation is needed, right? They change the position based on observation. I mean, off observation. So I receive it in my brain, but am I really receiving the signals in my brain to make it out through what the neuroscientists or neurologists call colostrum that orchestrates it once it receives it and orchestrates it cognitively to allow you to have a sense of cognitive expression. So yeah, I mean, you could say it's doing it in the brain, but observation is still needed.
Okay, let's go back to the argument about what's his name, Stuart Hammeroff. By him being an anesthesiologist, right? And he explained the microtubules, right? So now if he explains the microtubule and how it moves in a wave-like length or whatever. Yeah, and we know that there is light there for the electron to be able to bounce back and yeah, if we know that, then it has to be somewhere in the brain. So obviously he kind of showed and proved that through his study.
He showed and proved it, but the brain is receiving the signals and making it out within the brain. It goes. So for example, everything is based off of signals. So your brain, like for example, your observation, you're looking at me. I'm receiving signals right now from this phone, and my eyes is absorbing it, making it out in my visual cortex, right above my cerebellum, and making it out cognitively for me to see what color you are, the radiance of the colors is giving off. The phone is black. I'm looking at your face. I'm looking at my avatar with the A on there, but I'm receiving it in my brain. Does it exist in my brain without an organism there to receive it? You get what I'm saying? So, for example, when neuroactivity, when neuroactivity stops and you completely lose oxygen, and neuroactivity stops completely, and there's nothing there to observe anymore because you're dead. You lost ATP, adenosine triphosphate, organism dried up, no oxygen, no nothing. Everything is decomposing. What really were you the whole time? Or what were you? You were, everything was only vital as long as the organism was able to. Exactly. You were just atoms. But here's the thing. Here's the thing though. But the atomic structures had to be alive and have stable chemical reactions to determine if you were alive, right?
Right.
Everything is receiving signals and making it out as long as you have a vital functioning organism there to receive the signals to make out chemically. So you ask the question. The answer is paradoxical. Yes, it's in the brain, but the brain is receiving a signal from other places in order to make it out in the brain. You get what I'm saying?
Yeah.
It's a paradoxical answer for me.
Yeah, I mean,
because the observer is very needed in order for those waves to collapse in a particle and to be made out to whatever is going to be made out to. The witness.
Right. Okay. But again,
it's like a virus. It's like a virus that depends on a host. Viruses depend on hosts in order to do. So that's what I'm saying. Seems like to me, consciousness needs a receiver for it to be made out, and it uses quantum particles as a vehicle to transmit the information as it bounces around. You get what I'm saying?
Right. Now you basically saying the same thing that I was trying to say, but I just couldn't explain it in that manner because you're more well studied in this than I am. But
yeah, but you're a genius though. You're doing good, Tiffany. I love what you're doing. You're getting it cracking. So no, you doing your thing, sister.
Right. But that's exactly as what I was trying to explain. Like you basically said it. You just said it right there. Just how the activity is. So basically the consciousness is receiving something through the quantum. So you just explained it. You kind of took my thoughts out and just put it into translation.
Right. So and I agree with you on that angle. But at the end of the day, I think the only thing that exists is what's the ground of all being, and the ground of all being is consciousness. I think that everything is made out is phantoms and things is going to deteriorate. Reality itself is not permanent because it's subject to change. Consciousness is all that ultimately exists at root. You know what I'm saying? You get what I'm saying?
I mean, yes, consciousness. But again, the question goes back: how did consciousness exist? Well, I think we got the answer, but I say I think. Okay, I think
that's a healthy thing because we do think. We don't know ultimately, but yes,
we don't know ultimately. Yeah, so I think that we have an answer, and that answer will be through quantum physics. But it's just has to be it has to be more research and more studies to actually prove, to actually be able to make a ground argument to bring about a conclusion. But other than that, quantum physics, it seems like it's close to being able to answer how consciousness operates within us. And
I think quantum particles or quantum physics is the medium between us and conscious, or subject-object split. You get it? Subject-object split. Subtle, the dynamic, and what's manifest. In between, quantum particle is the bridge. Consciousness is just fly, but it uses quantum particles as a vehicle in order for us to even get the expression that we see, that which I'm receiving right now, looking at you, you hold it up, we holding it like this is it. You know what I'm saying? So
okay, now let's ask a question. Now we got the electron part out the way. Now let's talk about how protons and neutrons. Now protons and neutrons, right, and matter. Yeah. Where does protons and neutron and let's scratch out matter. Let's talk about the black body. Okay, let's put the black body in. Let's replace the black body with Let's replace matter with black body. All right, let's look at protons and neutrons. Where does it place into this? Now, if electrons is bouncing off, right, and it got the double slit theory going on, etc., where does the proton come into play? Where does the neutron come into play?
Well, a proton is 2 up quarks and 1 down quark, and a neutron is 2 down quarks and 1 up quark. A neutron is slightly heavier than a proton. Protons itself is nothing but quarks tangled together, the same way molecules is a collection of atoms. Protons and neutrons is a collection of quarks, primarily the up and down quarks. That's all it is. And quarks is those quantum particles that ultimately is that really what exists before the accumulation build up. The electron itself is like the after effect pressure, friction from that's combined in between, if you understand what I'm saying. But the proton and the neutron itself is quarks, tangled. 2 up quarks and 1 down quark forms a proton. 2 down quarks and 1 up quark forms a neutron. That's why at the base of everything and at the ground of all tangible, what we call tangible being, is ultimately just the quantum particles. But that behavior is undefined because we only understand quantum particles once it's accumulate collectively to form into the larger levels of mass as the building block, and that's what can be calculated and measured through physics. Quantum particle behaviors you can't determine that, the quantum particles behavior. But wait
a minute, hold on. You can't determine that because you got to use mathematics, right?
You can use mathematics
and stuff come in, right?
You can use mathematics, but when it comes to quantum particles, they can't be detained like atoms and molecules in simple behavior on the objective surface. This is what's crazy about the quantum particles. You even got the Higgs boson particle, and the reason why they call it Higgs boson particle the God particle, because Peter Higgins couldn't detect it, and he said goddamn particle. When you're dealing with quantum particles, like if you look it up right now in the behavior of quantum particles, you can calculate the after effect of quantum particles, but you can't really calculate quantum. They're too small and they move in their own direction. But you can mimic it. We know that protons is 2 up quarks and 1 down quarks, and those are the only those level of quarks is responsible for the tangible universe. The up and down quarks. Quarks move in 6 flavors: up, down, charm, strange, and top and bottom. But look it up right now if you get a chance. Look up could quantum particles be measured?
Okay, you know what? I will do that right now. You over there eating ice?
Oh yeah.
Hold on. Okay. Let me see. Now, I'm over here. I'm trying to see, can it be measured? Let me look at measurement in quantum mechanics. Maybe I have to go through that. So, all right, hold on. So I'm gonna go ahead and post it up. Yeah, I heard y'all say, okay, he eat ice. Okay, well. I thought you was over there sipping on that codeine, that lean. I was getting a little concerned. I said, wait a minute, and go on there drinking that lean. Let me stop. Let me not speak that into existence. That ain't no joke though. That lean stuff will kill you though. But anyways, measurement in quantum mechanics. So it says here in quantum physics, a measurement is the testing of or manipulation of a physical system in order to yield a numerical result. The prediction that quantum physics makes are general and probabilistic. The mathematical tools for making prediction about what measurement outcomes may occur were developed during the 20th century and made use of linear algebra and functional analysis. It says quantum physics have proven to be an empirical success and to have wide-ranging capability. However, on a more philosophical level, debates continue about the meaning of the measurement concept. So far, that's what I'm getting about the measurement in quantum mechanics. Ngozi? Ngozi, are you there? Okay. Okay, so he'll be back, but yeah, that kind of sums up, the argument that I was making. Basically what he was saying, he just put it together. He explains like using quarks. So basically he was using quantum particles. So while I'm waiting for him to come back, I'm gonna look up what quantum particle is. All right, so well, let's look on the free particle. So I see free particle here, but I don't see quantum particle. So maybe this helps me to get the answer. So it says, in physics, a free particle is a particle that in some sense is not bound by an external force, or equivalently not in a region where its potential energy varies. In classical physics, this means the particle is present in a field-free space. In quantum mechanics, it means the particle is in a region of uniform potential, usually set to zero in the region of interesting, since the potential can be arbitrarily set to zero at any point in space. All right. So he asked a question, can it be calculated? Let's see. Quantum free particle, mathematical description. A free particle with mass in relativistic quantum mechanics is described by a free Schrödinger equation. So where is the wave function of the particle at position r and time, the solution for a particle with momentum p or wave vector k at angular frequency or energy is given by the complex plane wave. So therefore, it says, as for all quantum particle free or bound, the Heisenberg uncertainty principle is clear that since the plane wave has definite momentum, the probability of finding the particle's location is uniform and neglectable all over the space. In other words, the wave function is not normalizable in Euclidean space. These stationary states cannot correspond to physical realizable states. So, okay, so he back. All right, and Ngozi, you back?
Yeah. So what was your answer? I'm right here. So what was your answer?
Okay, so right here I'm on where it says free particles. And I hear some echo in the background. Okay. And Ngozi? Okay. So according to
No, I said since I'm a mute. I'm a mute as you go in. Go ahead.
Oh, okay. So I'm on the free particle source, and so right here, according to where it says quantum free particle, there is a mathematical description. That will be the Schrödinger equation and matter wave. So according to this, I don't know if this is going to be the exact answer, but
only when forms in particles. Waves itself behavior is unpredictable, but once it collapses into particles can be measured. You get what I'm trying to say?
Okay, say it one more time.
Waves in position can't be measured. When you're talking about vectors and different things, or the vector behavior, but when waves collapse into particles can be measured based off observation. That's the trick to quantum physics. But as waves, what's the position? What's the stationary process of a wave before it collapses into a particle? Ask yourself the question. So what's the answer? Is it a paradoxical answer, or is it straight yes or straight no?
I mean, well, the waves can be even, it can be even stationary, or it could be in motion. That would be my answer. Ngozi? Ngozi? Ngozi. Okay. He might be a little busy. But yeah, my answer to that question, to Brothers Ngozi question, I think that wave can either be stable or it can be in motion. But if it's stable, then it's not a wave. It's just like a straight line, basically, because nothing is moving. But if it's in motion, then it will be a wave. Yeah. I don't know where Ngozi went, so I'm trying to see where he at.
Tiffany, I'm back. I'm sorry. I was taking care of business. Go ahead.
Okay. So to answer your question,
yes.
As far as wave is concerned,
yes.
Now it could be stable, or it can be in motion.
In motion. Mm-hmm. Stable in motion. Right. Mm-hmm.
All right. Let's just say the wave is curved up like a U.
Uh-huh.
Right, but it's not moving.
Uh-huh.
Right, it's stable. But if it's in motion, right? If it's in motion,
uh-huh.
then it's moving. But if it's a straight line and it doesn't make any type of wave, then it's just a straight line.
So what's what's the answer though, sister? Could quantum particles be made? It's paradoxical, right?
I mean, I guess you could. Yeah, you could say that.
And that's the thing. And that's the thing about quantum particles. They're unpredictable.
Well, okay, so it go back to the electrical charge and the magnetic. I mean, electrical field and magnetic field, right?
Electromagnetic field, weak nuclear force, strong nuclear force, and gravitational nuclear force. Mm-hmm.
Right. Okay. Yeah. So basically, electric basically means that it's stable, and magnetic means it's moving.
Yes.
Okay.
So we and those behaviors in motion, in particles, and in motion can be measured. That's mass at its best. Those are the selective forces that's responsible for the physical reality we live in. Weak nuclear force, strong nuclear force, electromagnetic nuclear force, and gravitational. So, and then if we understand the 4 levels of matter or 4 forces of matter, that's the forces that governs over matter. If we understand what makes up reality, solid, liquid, gas, and plasma, all those things can be motion. All those things can be measured. They can be measured. But the quantum particles at root, that's unpredictable, only in motion or when waves collapse into particles, those positions in the stationary places that it takes its role in positioning can be measured. It can be calculated. But quantum particles at root are unpredictable. Only, and then this is when they talk about the observer and all that other stuff. You get what I'm saying? So the answer is it's a paradoxical answer.
So, because you never know when it's going to move and when it's not going to move, basically.
Quantum particles. Go back and listen to the other show we did. We explained it all good.
Right.
So now we're going back to it. So it's like, it ain't no straight answer when it comes to quantum particles. It's impossible. And in fact, on the other show, we even went through the double slit theory. We talked about that. We talked about the behavior. We talked about it a little bit on the other show me and you did together.
I just got to go back and recall because I don't remember you talking about the double slit theory.
We talked about it. I brought it up. You got to excuse me. I'm over here zoning out, with my eyes. And,
I hear you.
So, yeah.
I hear you. Yeah. So, but yeah, we did talk a little bit, but we're talking about, bringing into the relationship with consciousness. So now that we talk about the quantum particle, right, and the wave and whatnot, how would it affect the consciousness?
Uh-huh.
Yeah.
Yeah.
Now I'm asking how would it affect the consciousness?
How would
How would it
affect
affect the
consciousness?
neurons? The quantum particle or the quarks, how would it affect the neurons, the neuron cells inside your brain, and how would it affect consciousness now that we know that the wave
If the
of the particle?
if the observer is there interacting with the quantum activity, it affects consciousness all day. Consciousness affects that all day. It's going backwards and forth. You get it?
Mm, 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 hmm. Oops. Okay, so yeah, so anyways, with that being said, all right, let me, until I can get him back on here. I appreciate you, Phillips. Thank you. Yeah. So let me go back on here to the information until it goes to come back on here, if he can come back. All right. So again, you guys can check this book out. It's called Consciousness and the Universe, right? Quantum Physics, Evolution, and Brain and Mind. Okay. So I'm gonna leave the title up here so you guys can look at it. You guys want to find out some information. All right, I'm gonna leave it up here. So just look it up: the consciousness and the universe. Yeah, I gotta drink me some water because I've been doing a lot of talking. All right. Okay. So let's go to the quantum approaches to consciousness. I meant to ask him something about the string theory. And yeah, I want to ask him about the string theory. That's why I meant to ask him. But hopefully I'll get him back on here. All right. So let's look at the quantum brain. All right, since we're talking about consciousness and all of that, let's look at the quantum brain. So it says, in this session, some popular approaches for applying quantum theory to the brain states will be surveyed and compared. Most of them speculative with varying degrees of elaboration and viability. Okay. So going down here, it says there are quite a number of accounts discussing quantum theory in relation to consciousness that adapt basic ideas of quantum theory in a pure metaphorical manner. Quantum theoretical terms such as entanglement, superposition, collapse, and complementary and others are used without specific reference to how they are defined precisely and how they are capable of a specific situation. For instance, conscious acts are just postulated to be interpretable somehow and analogously to physical acts of measurement or correlation, and psychological systems are just postulated to be interpretable somehow analogically to physical entanglement. Such accounts may provide fascinating science fiction, and they may even be important to inspire nuclei of ideas to work out in details. But unless such detailed work leads beyond vague metaphors and analogies, they do not yet represent scientific progress. Approaches falling into this category would not be discussed in this contribution. All right. And then goes on to say a second category includes approaches that use the status quo of present-day quantum theory to describe neurophysiological and or neuropsychological process. Among these approaches, the one with the longest history was initiated by von Newman in 1930s, later taken up by Wegener and currently championed by Stapp. It can be roughly characterized as the proposal to consider intentional conscious act as intrinsically correlate with physical state reductions. Another fairly early idea dating back to Riccardi and Umezawa in the 1960s is to treat mental states, particularly memory states, in terms of vacuum states of quantum fields. A prominent proponent of this approach at present is Batillo. Finally, there is the idea suggested by Beck and Eccles in the 1990s, according to which quantum mechanical process relevant for description of exocytosis at the synaptic cliff can be influenced by mental intention. The third category referred to future developments or generalization of present-day quantum theory. An obvious candidate in this respect is proposed by Penrose to relate elementary conscious act to gravitation-induced reduction of quantum states. Ultimately, this requires the framework of a future theory of quantum gravity, which is far from having been developed. Together with Penrose, Hameroff has argued that microtubuli might be the right place to look for such state reduction. All right. All right. So, so yeah, that's the information. It pretty much goes back to the original argument that was made and whatnot. So the question I have, what does the string theory has to do as far as with consciousness and quantum physics is concerned? Does it play some type of significant role? That's the question that I have. So let me see if I can get Brother Ngozi back on here. So yeah, that's my question. Does it you read about something that can be influenced by mental intentions? Yeah, I was reading an article from Plato .stanford.edu, which is Stanford Encyclopedia of Philosophy. Okay. So basically, yeah, it's going into the philosophical concept of the whole idea of the conscious brain, like the theory and stuff like that. I think let me go back and see what you're talking about. Yeah, so I read something. I'm trying to find it because I know what you're talking about. I read it on here. I think it was the one about the quantum theoretical terms such as entanglement, superposition, collapse, contemporary, and other are used without. Hold on. Oh, okay. Yes, it's the second category. So yeah, right here it says a second category includes approaches that use the status quo of present-day quantum theory to describe physiological or neuropsychological process. Among these approaches, the one with the longest history was initiated by von Neumann in 1930, later taken up by Wagner and current championed by Stapp. It can be roughly characterized as the proposal to consider intentional conscious as intrinsically correlated with physical state reduction. Another fairly early idea dating back Riccardi, whatever, and Umezawa, whatever, in the 1960s is to treat mental states, particularly memory states, in terms of vacuum states of quantum fields. A prominent proponent of this approach at present is Vatilo. Finally, there is the idea suggested by Beck and Eccles in the 1990s, according to which quantum mechanical process relevant for the description of exocytosis at the synaptic cliff can be influenced by mental intentions. Yeah, so these were like different studies regarding to the quantum theory, right? So one approach was dealing with the conscious act and the relation of the physical state reduction, and the other one deals with like the mental intentions, which was suggested by Beck and Eccles in 1990s. Yeah, so that's where I was reading that, Philip. Yep. So what you want me to like get some more information about it and like post it up, or if that's what you want me to do, you want me to find more information, I can do that. Okay, cool. No problem. All right, no problem. I can do that. Let me look up the individual's name. All right. So here's the article that I have. So this website, hold on. I got you. Hold on, give me a second. Hey, sorry about that, Phillips. Yeah, I'm gonna go ahead and I'm gonna pull it up for you. As a matter of fact, let me pull up the name though. All right. All right. So, anyways, let me go ahead and present this information. So, I did find some information on the quantum aspect of brain activity and role consciousness. Okay. So, it's on this website right here. If you can see it. It's called The Quantum Aspect of Brain Activity and the Role of Consciousness by F. Beck and J.C. Eccles. Right? So the abstract says the relationship of the brain activity to conscious intentions is considered on the basis of the functional microstructure of the cerebral cortex. Each incoming nerve impulse causes the emission of transmitter molecules by the process of exocytosis. Since exocytosis is a quantum phenomenon of the presynaptic vascular grid with a probability much less than 1, we present a quantum mechanical model for it based on a tunnel process of the trigger mechanism. Consciousness manifests itself in mental intentions. The consequent voluntary action becomes effective by momentary increases of the probability of vascular emission in the thousands of synapses on each pyramidal cell by quantitative selection. So let me go to the actual article in itself. All right. All right. So, my voice kind of giving out on me. Oh boy. All right. So let's go ahead and let's look at the article. Now, let me look at the actual article. So, all right. So hopefully you can see the article if you can. All right, so let me just zoom the article up. Hopefully you can see the article. Maybe I need to kind of zoom back a little bit. All right. So it says quantum aspect of the brain activity and the role of consciousness. Now this came out on July the 21st, 1992, contributed by John C. Eccles. All right, and it was published under biophysics. Okay. So, which is under the pnas.org website, okay, etc. All right, so let's go. Let's see. Where do I begin? I don't want to. Well, you see the paradigm. I mean, the diagram, right? If you see the diagram, here's a diagram here that showed the example of what they were talking about. All right. But let me go ahead and just read like the first, let me just read the first paragraph. Let's just read the first paragraph. All right. Because it's a lot. But it says there has been an increase in interest in the relation of quantum mechanics, brain's activity, and consciousness. On the part of quantum physics, the impetus came from the interpretation of the measuring process, which is still on debate, even after more than 60 years of overwhelmingly successful application of quantum theory. However, there is the question from neuroscience, whether quantum action is needed to understand the functioning of the brain in its subtle relations to experience, memory, and consciousness. It was Wagner in his stringent analysis of the of the consequence of measurements in a Stern-Gerlach experiment, who first speculated that the von Neumann collapse of the wave function actually occurs by an act of consciousness in the human brain and is not describable in terms of ordinary quantum mechanics. More recently, similar ideas were put forward and partly combined with Everett's many-world interpretation of quantum theory. Other authors have related quantum theory to consciousness on the basis of the usual interpretation of the state vector as a superposition of actualities or propensities and proper nomenclature. Not much connection has been made, however, to empirically establish facts of brain's physiology, nor have those authors attempted to locate a quantum process in functional microsites of the neocortex. In this work, we contribute to filling the gaps by putting forward a quantum mechanical description of Bhutan exocytosis. The next session gives an outline of the structure and activity of the neocortex as introduction to the quantum mechanical model. This is set up in the subsequent session. Finally, the hypothesis for a coherent coupling of the individual probability amplitudes is introduced. In this model, action becomes possible by influence of a conscious will. All right. So did you get that? Did you get that, Phillips? Okay. All right. So I'm just going to read the neocortical activity. So it says Figure 1A illustrates the universally accepted cis laminae of the neocortex with two large pyramidal cells in lamina, three in lanima 2 and 2 in lanima 2. The pyramidal apical detritus finish in a turf-like branching in lamina 1. There is a agreement by Peter, and I don't know how to say his name, but I'm not going to try to pronounce it. It's pronounced, it starts with an F, but anyways, I'm going to skip that, and their associates, that the apical bundles or clusters diagrammically shown in figures 2b are the basic anatomical units of the neocortex. They are observed in all areas of the cortex that have been investigated and in all mammals, including humans. Okay, it says it has been proposed that these bundles are the cortical units for reception, which would give them preeminent role since they are composed essentially of dendrites or detrites. The name detron was adopted. So then it goes on to talk about Figure 1B illustrates a typical spine synapse that makes an intimate contact with an apical dendrite, a pyramidal cell. The osseous structure of the such a synapse has been intensely studied by Eckert and his associate. All right, so I'm gonna kind of skip down a little bit. Okay, go down here. It says a nerve impulse propagating into a Bhutan causes a process called exocytosis. Most nerve impulse evoke a single exocytosis from a PVG. This limitation is probably due to the vesicle being embedded in the paracrystalline. All right. Exocytosis is the basic unitary activity of the cerebral cortex. Each all or nothing exocytosis or synaptic transmitter result in a brief exotary postsynaptic depolarization summation by electrotonic transmission of many hundreds of these milli EPSPs is required for an EPSPs, right, which is the abbreviation for the excitatory postsynaptic depolarization. Anyway, it's a large enough to generate the discharge of an impulse by a pyramidal cell. Excuse me. The impulse will travel along its axon to make effective excitation as its many synapses. This is the conventional micro operation of a pyramidal cell of the neocortex, and it can be factually described by classical physics and neuroscience, even in the most complex design of network theory and neuronal group selection. All right, so just to start right there. So basically, that's their argument claim about how the brain activity and the role of consciousness. So due to quantum physics. So basically, they have made this argument before. Basically, they have made that argument before. What's those two guys' name? Before Penrose and Hammeroff. So those they were one of the first to actually come up with that argument about the quantum and the brain activity and stuff before Penrose and Hammeroff did. It says, I think that especially when people move objects with their mind, I got it. I don't know how you move an object with your mind. Because you just went to parapsychology on that. When you talking about moving object with the mind, that's parapsychology. You just went there. You just went to the parapsychology level. Moving objects with their mind. Let's see. I mean, you can't. No, that's parapsychology. That's what you just described. Parapsychology, Philip. Mm-hmm. All right, but let me look up ES. Oh, I know what you're talking about. Extraordinary. What's it called? Extraordinary sensory. Let me look that up. Extraordinary. Okay, I know what you're talking about. The extrasensory perception. Extrasensory perception. That's what you're talking about. Yeah, extrasensory perception. Yo, yeah. So extrasensory perception would deal with parapsychology, right? The ESP, that's dealing with parapsychology. That's where it would fall under, right? Because you just said when people move objects with their mind, that would be more like parapsychology. I thought it was exocytosis. So you thought ESP was exocytosis? I don't think so. Hold on. Is it exoptosis? My thing is, hold on. Because what you were just saying, the last statement that you made, when people move objects with their minds. Hold up. Hold on. ESOP. Yeah, Avery, I'm on YouTube. Yes, I'm on YouTube and Facebook. I thought what he say. I thought the word you were reading is exocytosis was ESP. I probably misspelled exocytosis to get ESP. Oh, okay. Nah, the only ESP I know of is the astral sensory perception. That's all I know, and that's dealing with more like that parapsychology type of stuff. That's the only one I know. No, I was saying the other word. Yeah, the word that you had it spelled correctly. Let me see. Yeah, exocytosis. Yeah, this word right here. This is the one that you spell ESOCYTOSIS. Exocytosis. Yeah, that's the one that you had correctly. That's the one that you spelled correctly. Yeah, you kind of threw me off. You kind of threw me off because I thought you was talking about when you was making a statement about people moving things with their mind. I thought you were talking about parapsychology. Yeah. Nah, you good, Anthony. Yeah, I've been here almost 2.5 hours. Yeah, greetings. How you doing? Yeah. All right, but you know what? I actually, believe it or not, Phillips, I actually came across some information where people try to bring about quantum psychics, but that's kind of pseudo because what is quantum psychics? If I can even, as a matter of fact, I can show and prove that. Yeah, I thought you would, because there's some people that try to. As a matter of fact, here's this lady right here. This lady got a book. Hold on, let me. No, you can't move the mind with your no. You can't move objects with your mind. You can't move objects with your mind. It's not gonna happen. Now you can. What you can do is you can sit there and look at something all day, and you can become very dizzy. But you can't move no object with your mind. But what you can do is look at an object. Like if you concentrate on an object for a very long time, if you concentrate on an object for a long time, right, you eventually will start daydreaming. When you start daydreaming, you'll like be kind of like hypnotized a little bit, or kind of like be a little dizzy because you're staring at something for a long period of time. So it's like your mind starts to wander off, but your mind can't move no object. It may look like you're moving an object, but you're not. At the end of the day, that itself will be an illusion, because the object is still going to be at a standstill. It's just your mind moving. It's like your mind is in motion. You know what I'm saying? Your brain is in motion. It's making you think that the objects are moving, but it's not. I hope that makes sense what I'm saying. All right. But that's because you asked me. You said, if I asked you to remove your left earring and you do it, then I did it. You asked me to do it. But then it still be up to me if I wanted to remove my left earring. If I don't remove my left earring, then you didn't do anything. You didn't do anything. Now, in your mind, you may believe that you asking me to move it, but in all actuality, it's still there. So therefore, you really didn't do anything. So I don't agree with that. I don't agree that you can move objects with your mind. Like nothing is going to move. I mean, you can have it in your mind that an object is moving, but nothing is going to move unless you pick it up or unless it moves on its own, if that makes sense. All right, so there's this book about quantum psychics. I kid you not. It's kind of pseudo. It's kind of pseudo, but here it is. So there's this book called Quantum Psychic, but it is very pseudo because check it out. Scientifically understand, control, enhance your psychic ability. Tele-empathy, clair-empathy, clairvoyance, etc. And it was written by a lady named Teresa M. Kelly. But guess what? Again, that book is pretty pseudo because that's based off of belief system. That's not even based off of the reality. So yeah, so there is something dealing with quantum and psychic, but it's like I said, it's pseudo-scientific. Somebody put, thank you for keeping it based in reality, Miss Tiffany. Who can move objects with their mind? Nobody. You can't move no object with your mind. You can visualize it, but you can't move nothing with your mind. It's impossible. It's not practical. It's not practical. All right, so I've been on here for a long time. All right, so I have one last source. And this source is dealing with mind reality. So my reality kinds of go into what I was discussing about the concept of quantum physics and consciousness, but this one is just more so dealing with the universe and is being mental and things like that. So if you guys don't have it, I would encourage you guys to have it. This is something that I personally like to read and something that I like to entertain. So basically it's called My Reality, the Universe is Mental. And actually, I have a copy of this, but let's go ahead and let's look into this. All right, so it kind of goes into this spiritual component thing about the universe, but it's more so is like pantheism in a sense. That's basically what it is. It's more like a pantheistic ideology. So check this out. It says, the nature of all reality in the universal construct. Quantum physics states that everything in the universe is pure energy, differing only in rate of vibration. It says, we must understand that all things exist as energy, even beyond the ordinary physical dimension, to a realm where current scientific instruments cannot measure its rate of vibration. All things exist as energy from the lowest rate of vibration, the densest physical condensate of matter, all the way to the highest rate of vibration in the universe. The source, God, the entire universe, is a single super spectrum of universal energy. It says some people have the perspective that the physical universe of matter and energy was created and therefore may be destroyed. Information is uncreated and therefore indestructible and eternal. The Bible says that in the beginning was the Word, and the Word was with God, and the Word was God. The Word is information. Hence, the concept of the S, Y, and Z parameters of reality, matter, energy, and information, DNA, universal code, intelligent design, etc. So it says, but Einstein says that energy can neither be created nor destroyed. It is merely converted from one form to another. The universal equation E equal mc squared does not mean matter is converted energy. It means matter is energy. So as you can see, this kind of based on some type of spiritual concept, kind of like pantheism. But for me, it's just something that it's something good to read. Something that I like to entertain too. It's called My Reality. The Universe is Mental. Enoch Ton, creator of My Reality. So you can go on myreality.com and download it. Actually, you can download this book. So just go on the website and you can just get the PDF. But yep. Yep. Somebody says measuring rates of vibration. Intelligent design. So you know, it's the whole conflict about intelligent design versus evolution. Okay. Some people believe there's a combination of both evolution and intelligent design. Some people just believe that it's intelligent design / creationist and versus evolution. So, you know, it's a big debate about that though. Also, I got another book right here. This book is called The Ancient Origin of Consciousness. All right. So this is one last source I want to present to y'all. The Ancient Origin of Consciousness, How the Brain Creates Experience by Todd E. Finberg and John M. Mallet. All right. So let me look at something real quick. Okay. So in this book, right here, it goes into the different philosophical concept about consciousness as far as how it was studied during the ancient time, etc., and like different philosophy and things like that. So one of the things I want to look at is the multiple paths to solve the mystery of consciousness. It says, we propose that the hard problem of subjectivity remains mysterious because each field of study that is interested in its solution only addresses it from the perspective of its own set of question and answer. In this book, we endeavor to tackle the hard problem with 3 different approaches, each important in its own way, yet each incomplete. These three approaches are the philosophical, neurobiological, and neuroevolutionary domains. All right. So, as you can see, it also talk about the philosophical approach, the gap between subjectivity and objectivity. It says the major philosophical question is whether and how subjective experience can ever be explained by any objective scientific theory. Philosopher John Searle ascribes this difficulty to the first-person ontology of consciousness, where ontology has to do with being, reality, essence, or fundamental nature. And it goes on to say, consciousness has a first person or subjective ontology, and so cannot be reduced to anything that has third person or objective ontology. If you try to reduce or eliminate one in favor of the other, you leave something out. Biological brains have a remarkable biological capacity to produce experiences. With these experiences only exist when they are felt by some human or animal agent. You can't reduce these first-person subjective experiences to third-person phenomena for the same reason that you can't reduce third-person phenomena to subjective experiences. You can neither reduce the neuron firings to the feelings nor the feelings to the neuron firings, because in each case you will leave out the objectivity or subjectivity that is in question. So another argument is that is consciousness subjective or the objective, or if it's a combination of both. And I say that it's a combination of both. It's a combination of both being subjective and also the objective. So, yep. And of course, it goes into the 4 ontologically subjective features of consciousness. So, to delineate these gaps as systematically as possible, we identify 4 neuro-ontologically subjective features of consciousness. The NSFCS have in common the following features. They are ontologically subjective, and 2, there is explanatory gap between the way each is perceived by the brain versus the way each is observed or understood from the third person perspective. Now, check this out. It says the phenomena of qualia is the most frequently considered of the NSFCs, but we recognize three more: referral, mental unity, and mental causation. It is these features of consciousness that are the most resistant to scientific explanation. In attacking the problem of consciousness, this book will have to explain the neurobiology and the evolution of ontologically subjective features. All right. So, all right, so I'm just gonna read well, you know what? I'm not even gonna go any further, but you guys can go ahead and check this book out for yourself. And let me see what Phila is asking me. How to clock the speed of a neuron firing. That's a good question. Or if you're making a statement. I don't know how you do that. I would say that would be, you would have to use some form of equation to clock the speed of a neuron firing. You're gonna have to use some type of equation, mathematical equation for that. But yeah, you guys check this book out. If you haven't, please do so. I think that this is a very good book, and it goes into, the concept about consciousness and the different studies on it. So yeah, I'm gonna hold this book up. The Ancient Origins of Consciousness: How the Brain Created Experience. Todd E. Finberg and John M. Mallet. All right. Alrighty then. Woo, child, I've been on here for a long time. Y'all kept me going. Because usually I be on here and I get off, but y'all kept me going. Yes, it did. It spoke of the neuron firing. Yes, it did. Uh-huh. Yep. Y'all kept me going. So, with that being said, I appreciate every last one of y'all coming through. Thank you for watching, and thank you for your questions and your comments. I appreciate the dialogues that we have, and I appreciate Brother Ngozi for coming on here. And I hope you guys got something out of the conversation that we have. I hope y'all got something out of the video. I know some of y'all came late, so you have to start from the very beginning. But with that being said, y'all take it easy on yourself, and make sure you guys subscribe to the channel and hit the notification bell, share this channel, share this video, and all that great stuff. Check out more contents I have. So I'm gonna come up with more information, more subject about this. Yeah, so I'll make sure I do more of this very often. But until then, y'all, please take it easy and please be careful, because we're still in this pandemic. We're still dealing with COVID-19, and we also got this Delta variant virus going around here as well. So if you guys haven't got vaccinated, I would encourage you guys to do so. But it is your choice if you decide not to get vaccinated. But I encourage y'all to do it, you know what I'm saying, because it's very important, you know what I'm saying. But until next time, I'll talk to y'all later. This your girl Tiffany. Peace. All right.